today I'm going to discuss on a very important topic, a very decisive one, and the topic is that when and why should we learn algorithms, right? Basically, if we talk about today's world, our friends and peer groups, they all talk about learning new languages, right? So basically, if you see your friends talking about new languages, like they want to learn um Python, right? They want to learn Python, C, C++, Java, right? JS, HTML, and all those things. Like the list basically goes on and on, and it doesn't end, right? So, but is that the way? Like I want to say that there are many languages. I guess there are there can be infinite languages. Languages can't end because languages are nothing but they do the same thing in a different way. Like their syntaxes only differ. Basically, the main logic of any program remains the same in any language, right? So, is in that case, do you really think that the more number of languages you learn will go to help you, will going to help you, right? I don't think so because in any interview or any job placement interview set, they don't ask you that which languages do you learn or what are your prime languages. In Yeah, I agree that yes, knowing languages is good. That's gonna help you a lot, but still, the main thing lies in the algorithm. Like if I think like this, if this is the program, right? Okay, if this is the program, now this program is going to give me some output. That's also going to take some input. Right, input. Right. Okay, now this input to the program takes the input. Now it gives you output. Now this program can be written in many languages like Python, like C, like C++, like Java. Now this goes on, but they all do the same thing. They will give you the desired output, but the program you write, it has some logic. It has some statements, or you can say some conditions they require. Now all those things are important. How you write them, like how you use the perfect statements in the logic. Now if your logic, now if you solve some questions in any programming languages, you will see that any problem can be solved in many ways. They can be solved in many ways. Then what's the difference in that? The difference is the time complexity. If you have studied time complexity, you will better understand this. And if you haven't studied, then you can request me in the comment section to make a video on that topic. Like time complexity is quite important topic, right? Okay, so talking about this thing, the time complexity. Now this time complexity actually decides the uh, efficiency of an algorithm, right? Algorithm can be quite efficient having less time complexity, and it can be non-efficient having more time complexity. That depends on what logic you do use, right? But now what decides that? That is decided by a perfect algorithm. you know if I talk about some algorithm, like I can say that integer multiplication algorithm, or string matching algorithm, or nearest neighbor finding algorithm. There can be many algorithms to do that, but if you see, there is only one algorithm which is actually perfect in any case. Like if you say integer multiplication, I will prefer you to use the carrot soup algorithm. Talking about some recent news, there is some near and fast algorithm recently discovered, but still, till date, Karatsuba is the perfect algorithm for integer multiplication, right? You will study it. Okay, so I was talking about that. So basically, now if you know the algorithms, what what you're gonna do is you can select the perfect way of doing any program, right? If you have a problem, now you can solve in any logic, and you make sure that the logic is perfect. Now how you gonna know it's perfect? Because You have studied an algorithm that this logic has time complexity x and the other logic has time complexity y. So basically, if you know if x is greater than y, then you will see that yes, why should I use x? I will use y because it has less time complexity basically, and it will give me a better result in a less time, and its runtime is very slow, right? So basically, from all this, we actually know something like program amount means if you learn many number of programs, that's cool, that's fine, but before learning many languages you need to learn this. This is quite important. So basically, I will prefer you should know at least two or one of these languages, and after knowing that you should shift to algorithms, right? Yeah, after you shift to algorithms and after you complete that, then you can know the difference between any n number of logics and apply them to any number of problems, right? So basically this video was only for algorithms. Now hope you got a better idea about how and when to learn algorithms. Now talking about resources, I will prefer you to read algorithms from I will rather prefer you two books. One is Skyna Skyna is a good book for algorithms, and second one is very fundamental book, that's actually very popular book, that is fundamentals of algorithm fundamentals of algorithm. That's very popular one, that's very fat book, you know. This Skyna is actually available in net, you know, in Google. If you search Skyna you will get this. So basically that's cool. Okay, so I think you got a better idea about this, and hope you like this video. So uh, I will rather end this video on this note, and hope you get a better idea of how to and when to read algorithm. Thank you guys.